In this video, we're going to talk about complex ion formation. Now, we said in a previous video that metals, cations, transition metals, are good Lewis acids, electron acceptors. And the reason they are good Lewis acids is because they have empty orbitals that they can put those electrons in. And when a metal, transition metal's in solution, it's really never just like silver plus. It's going to have water molecules bound to it to form what's called a hydrated ion. Hydrated ion just means water surrounding an ion. Now, water is a Lewis base. The oxygen has lone pairs on it. These lone pairs will donate electrons to the silver, and you'll get this complex. So this complex is actually a complex ion. A complex ion is an ion that you get when you combine a cation with several anions or other neutral molecules. So they're not your binary ions like sodium chloride. You have to have multiple things binding. And the thing that is bound to your center atom, they are called ligands or ligands. Depending on where you're from, you'll call them different things. I call them ligands. Most other people call them ligands, though. So here, H2O is your ligand. Now, with these complex ions, you can actually replace what kind of ligand that you have attached to your central atom. So here we have the silver and water complex ion, but if we add molecules of NH3, this NH3 will form a stronger interaction with the silver than the water does, and so these waters will be kicked off and replaced with NH3. Usually, when you write these equations, we actually don't put that the water is surrounding this cation. Because we're an aqueous solution with the AQ, we're already assuming that this molecule, this cation, is surrounded by water, so we don't even bother writing it. And so when we add our NH3, we can ignore water completely, and this would be our formula. And so how do you know which complex ions will form? Well, again, it goes back to equilibrium. And here we have formation constants. It's the same thing as equilibrium constants that we had, where it is products over reactants. And you can see here we have some very big numbers, times 10 to the 21, times 10 to the 33, times 10 to the 41. Basically, the bigger the number, the more it will want to form that complex ion. So let's look at Ag. And let's say we had Ag in solution and we add three different counter ions, Cn, NH3, and S2O3. Which complex will form? Well, it's going to be AgCN2 because that has a bigger Kf. So when you're trying to form complex ions and you have multiple choices, usually go with the complex that has the bigger Kf. Right? And like I said, Kf is your formation constant. It is products over reactants, like all the other constants, all the other Ks we have learned this semester. And that's it for this video. I will see you in the next video.